All right, so let's talk about variance. So what we're talking about here is we're relating two variables, in this case x and y, and we're telling you how they vary, how they relate. Well, x and y, for this one, vary or relate directly. So what we mean by that is that when x increases, so if x is 1 and we increase it to 2, y will also increase. The question is by how much? Same thing, if x decreases, then y will decrease. And there's going to be some relationship there where, yes, both will go up, but they might not both go up evenly. So x might increase by 1, but that might cause y to increase by 4, right? Same thing in the reverse with going down. So in this equation right here, x and y are varying directly. X and y are on opposite sides of the equation. Sometimes you can see it written like this. Oops. X over y equals k. That's also valid, and if you prefer that, that's fine. I prefer writing it like this. So x and y are on opposite sides of the equation. That's easy for me to remember versus whether they're on top or bottom, but always on the same side. I like to think about different sides here. So x and y are on different sides because they are directly related. As x gets bigger, then y has to be bigger to catch up because they're supposed to be equal, right? K is a constant, so it's going to be a number like 5, so that's not going to change. So in order to make this balance, to make this equal, if x increases, y needs to increase to match it. Same thing, if x goes down, then y also needs to go down. That k is just some constant. And we're going to be solving for that constant to figure out exactly what the relationship is here. As x goes up by 1, how much does y increase by? Well, a lot of that has to do with what k is, what that constant is. So if we can figure out what that constant is, then we have a relationship. X is equal to 5 of whatever y is, for instance. Meaning that if x goes up 1, so let's say x is 5. If x is 5 and k is 5, then y must be 1. So if x goes up to 10, well, I've now doubled it, so now y has been doubled, right? Because k is going to be the same. So again, the main idea is that you need to know that x and y are on opposite sides. They're on different sides of the equation because they are directly related, and directly means both go up or both go down. X varies indirectly, or we can call this inversely. I often say indirectly because directly and indirect are opposites, and that's what this is. It's x and y are on the same side, even though they're going in opposite directions. And the reason for that is because x gets bigger, y needs to decrease. That way when you multiply together, they still equal the same number. So for instance, if x was 4 and y was 6, well then k must be 24, right? But if I increase x to 6, well now y's got to go down to 4. It's got to decrease to make sure it still equals 24. If x goes up to 12, then y needs to decrease down to 2 because 12 times 2 is 24. So they have to balance each other out by going opposite directions so they equal the same thing, right? If both increase, well then k got bigger, and that's not allowed because k is a constant. If both go down, then k got smaller, and that's not allowed because k is a constant. If one goes up and the other stays, well, k still got bigger because this one went up, and that's not allowed because k is a constant. So they have to balance each other out by being indirectly proportional or varying inversely. So they have to go opposite directions here, and that's what this is saying. So for directly proportional or with direct variance, they're on opposite sides of the equation, and both either go up or both go down to keep k balanced. Here, to keep k balanced, they both have to go in opposite directions because they're on the same side of the equation. Another way to look at this is to have the y underneath the k over here, but again, I think that gets more confusing. Direct is different sides, and then inversely is same side. We like indirect. I think multiplication looks a little bit nicer than this thing right here. And then we have varies jointly, which is really just a fancy way of saying that a variable is directly proportional to two other variables. So we have z is directly proportional to x, and it's directly proportional to y. And the idea is that, let me scoot this up a little bit, as x and y, their product increases, then z has to increase. So pretend x and y are 2 and 3. Well, the product here is 6, so that's going to make z something. Well, if I increase that product by, I don't know, making x 7 and keeping y 3, well, now the product is 21, so z is going to increase by a certain amount. So the idea is that x and y, their product, after multiplying together, if that increases, then z increases. If the product of x and y decreases, then z also decreases. Now, the reason we have to talk about the product is because technically x could be gigantic and y could stay the same, and that would still make z bigger, right? So it's not individually. You have to look at the whole thing. They vary jointly. Joint as in together, right? So as x and y's product increases, z increases, and as x and y's product decreases, z decreases. So you have to check the product of these things first. And if the product stays the same, like if I have 2 and 3 here, that's 6. Well, I could also do 6 and 1. Both are the same product, but x and y are different variables. Well, because the product is still 6, no matter how you slice it, z would stay the same. So you have to look at that product to figure out what's going on. So let's do some examples of identifying these different types of variants and working with them to find out maybe what k is. So let's look at number 6 here. This is actually from your homework. I chose some selected examples. So number 6 gives you this table of x values in the top and y values in the bottom, and it asks you to figure out whether this is a directly proportional relationship, an indirectly proportional relationship, or none of the above. So those are our three options. So first things first, you should notice that x is increasing, right? As we go to the right, x is going up and y is going down. So we have an opposite relationship here. So one way to write that would be x is going up while y is going, where'd my red marker go? Going down. And the reverse is true. If we go from the right to the left, so from going to the right, we have x increasing, right? And y is decreasing. But if we go from the left, then you could say, well, x is decreasing, 32, 16, 8, 4. And y is increasing, 4, 8, 16, 13. So it's really depending on how you look at it. But we know from earlier that whenever we have one of these situations, x going up, y going down, or the vice versa, we have indirect variance. So we have x times y equals k. So we're dealing with this. We're dealing with x times y equals k because this is indirect, or at least we think it might be. We know it can't be direct because direct would imply as one does, the other does the same. So if this was going up and this was going up, we'd have direct, right? But this looks like an indirect. And so we have to ask this question, is it indirect? And the way we find out is we take x and y for any pair here. And if they equal the same k for here, 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 and here, then we have indirect variance. So if I take 4 and 32 and I plug them into this indirect equation, that will give me that k is 4 times 32. Well, 4 times 30 is 120, and 4 times 2 is 8, so that's 128. Now, is this true for all of these? Well, we can check that very quickly. 8 times 16, does that equal 128? Well, 8 times 16. If you notice, we divided 32 by 2, and we multiplied 4 by 2, so that should be the same number. That implies that k is 8 times 10, which is 80, 8 times 6, which is 48. Add them together, that indeed is 128, so that checks out. You can do that for 16 and 8 in reverse, right? That's going to be the same thing, so that'll check. And 32 and 4 will be the same thing as our 4 and 32 from earlier. So all of these have a k value of 128. They all have the same k value, which means this indeed is indirectly proportional, and this is the equation. X times y equals 128. They are indirectly proportional, or indirectly related. So that is indirect, or you could also say inversely related. For number 10, just taking a peek. Number 10, x is increasing. So let me write that. X is increasing. And you notice that in the bottom, y is decreasing. Okay, well, we have opposite things going on here. We could also read it from the other side and say that x is decreasing. Whoops, I should write this in red, shouldn't I? X is decreasing and y is increasing. But again, no matter how you slice it, they're doing opposite things. So this is potentially inversely or indirectly proportional. So I will ask this question, is it indirect? If so, we should have x times y equals k going on. So I look at this right here, and I notice that 11 and 15 are a pair. So 11, that's 11 times 15, should equal whatever our k is, which that implies that k should be 15 times 10 is 150. 15 times 1 is 15, so if I add those together I get 165. So k should be 165. Now if I check this with another xy pair, 13 times 13, well I know 13 squared is 169. So this would imply that k is 169, and these do not match, which means this can't be indirect. In fact, this is not applicable. It's neither indirect nor direct. There's some relationship here, as you can tell, right? We have 11, 15, and 15 and 11, and 13 and 13 here. It kind of looks like the last one, whereas one goes up, the other goes down in the reverse order, right? But it is not indirectly proportional because there's no constant k that works for all sets of these variables. So there's no constant k that makes 11 and 15 match and 13 and 13 match, right? One's 165 and the other is 169. So this is not applicable. It is not indirect, nor is it direct. Looking at number 11, let me grab another piece of paper here. Looking at number 11, we have x increasing, and it looks like y is also increasing, right? 30, 42, 54. So y is also increasing. And again, you could look at it like this, or you could say, hey, if you go from right to left, x is going down and y is going down. But really what we're seeing here is that, hey, look, they're doing the same thing. They're matching each other. So what we have here is potentially a direct relationship. And if it is direct, it should have the relationship that as x equals k times y. So notice when we were talking indirect, x and y were on the same side, right? And now that we're talking direct, x and y are on different sides. Maybe it's easy to memorize that with direct and different, although I do not encourage memorization. So x equals ky is what's going on here, if this is direct. So let's check our table and see if this makes sense. So when x is 5, it says, that should equal k times whatever y is. Well, y would be 30. Well, if I do some quick math, I find out that this implies that k is 5 divided by 30. Well, that's 1/6. Okay. Well, does that work for 7 and 42? Well, if I have 7 here, equals k times 42. Well, this should imply that k is 7 over 42, which is also 1/6. So that looks promising. And let's check the last one. So now we have 9 and 54. So 9 is our x, and that should equal k times whatever our y is. And we said y was 54. Move this up a little bit. Well, this implies that k is 9 divided by 54 when we move that 54 over by division, which is also 1/6. So yes, these are all the same, which means this is directly proportional or directly related. And the equation that we have is x equals 1/6 of whatever y is. Now, I didn't mention this before, but another way to write this is to switch the x and the y. And in this case, y would equal 6x. And you can rearrange that equation on your own here. You can move that 1/6 over by multiplying, and you get 6x. So either of these would work. In fact, there's always two ways to represent one of these equations, either direct or indirect. Either answer would be acceptable, and I hope you see why. If I take a big number and times it by a sixth, I get a smaller number. If I take a small number and multiply it by 6, I get that big number. It's, potato, potato. All right, so I think we've been able to identify direct and indirect now, and when something is neither. Now let's get into one of these problems where it tells us how they relate, and it wants us to write the expression and find out some variables here. All right, so looking at number 12, it says z varies jointly with x and y. And if you remember earlier, we mentioned jointly is when z equals k times xy. So z varies jointly with x and y. That's what we're talking about here. So let me write that down. So z equals k times xy. Remember, it's kind of like z is directly proportional with both x and y. So it says find z when x equals 4 and y equals 8. So we want to know z at x equals 4 and y equals 8. And they give us that z equals 7 when x equals 2 and y equals 7. Okay, so let's pull this up here. All right, so when x is 2 and y is 7, z is 7. So let's plug these numbers in. That's saying that z equals 7. K we don't know yet. It says x is 2 and y is 7. Okay, well, we can solve for k and find our constant that's going to be true no matter what, right? That constant's always some number, no matter which x, y, or z we're talking about. So what this tells us is that 7 equals 14k, which implies that k must be divided by 14. 7 over 14 is a half. So k is a half. So our relationship is z equals 1/2 xy. Cool. So that's the relationship between x and y and z. So if we know that x is 4 and y is 8, we can find out what z is, because now we know what k is. So what does z equal when x is 4 and y is 8? Well, half of 8 I'm going to do in my head, that's 4, and 4 times 4 is 16, which means this implies that z equals 16. And there's our answer. So z is 16 when x is 4 and y is 8, because we know that whatever x and y multiply together, you take half of that to get 16. Well, 4 times 8 is 32. Half of that is 16. Number 13. Let's see if I can read it. Z varies directly with x and inversely with y. So there's two things going on here. Z is varying directly with x. So z is our main variable. That's going to go on the left side. It varies directly with x. Now remember, direct is opposite sides. So k and x are going to be on the same side. So z varies directly with x. Cool. But it also says it varies inversely with y. So that means y is going to be on the same side as z. So there's our equation. Z varies directly with x and inversely with y. Then it says, find z when x equals 4 and y equals 8. So z equals, we don't know, at x equals 4 and y equals 8. But we do know, it says, that z equals 10 when x is 5 and y is 2. So we do know that z equals 10 at x equals 5 and y equals 2. Okay, cool. All right, so let's plug in what we know and find out what k is. So z is 10, and it says y is 2. Again, it's careful not to mix these up. Don't plug in x here just because it's the next one over here. And then we have x, which is 2. Again, I almost plugged in that last one there. X is 5. Y is 2. And now I can solve for k. Well, I know 10 times 2 is 20. And that's going to equal 5k. Then when I divide by 5, this implies that k equals 4. So now that I know k is 4, this is the relationship between z, x, and y. So now when I say that x is 4 and y is 8, I can find out what z is. So z is whatever y is. Z times whatever y is equals 4 times whatever x is. Well, it's saying x is 4, and it's saying y is 8. So now I know that 8z equals 16. And of course, this implies that z is 8 being divided over. 16 divided by 8 is 2. So z is 2. So those are our examples on variance. We've had an example where things are inversely related, as one is going up, the other is going down. We've had one where it's neither, even though it looks like it could be inversely related. Again, k wasn't the same for each set. We had one where it was directly related, where both were going up, or both going down, depending on how you look at it. We've also seen that varying jointly is just a fancy way of saying that z is going to equal kxy. X and y are on the same side. Z is on the opposite side because they're jointly proportional, otherwise known as directly proportional with both x and y. And we've been able to see how we can find k and then use that to find a different z. Same thing when z is direct with one and inversely with the other. It looks really complicated and confusing, but z is directly with x, so that means that z and x are on opposite sides, different sides, right? And that z and y are going to be on the same side. We can find k and then use that to find another random z. All right, so that is going to be it on variance. If you need more examples, send me a message and I'll get down to that. But I think that pretty much covers everything. In the next video, I will cover sketching of rational functions, and we'll break all that down with vertical and horizontal asymptotes and removable discontinuities, also known as holes.